So in this video we will see how to interpolate points to create a 2D map, and we will do it following two different methods. When you have to interpolate points to either create a raster file or to create another polygon file, then you normally have to do it from the vertical map. The first interpolation we will do is called a Voronoi interpolation. In principle, you could also do that from the table where you find the Voronoi. It will create a polygon file based on your table point data, but we will do it from the vertical map. In vertical mapper, you have to go to natural neighbor analysis and then click create regions from point to Voronoi. Right now I only have a point file, so that's the one we will use. You can adjust how coarse or how fine would you like your grid. If you have a very high defined, very heavy point file, you would choose medium or coarse, but my number of points is not too big to kill my computer, so I will choose fine. And then you just name the file somewhere where you can find it. I will call it Pathy Voronoi, and I would say OK, and I will just click OK. So now my original point file has been transformed into polygons, and the polygons are based on the distance between each of the points compared to all the neighboring points. So and this is how I look. When I have a lot of points, and then my definition is higher, like for example here, and then the polygons are smaller. When I have a long distance between points, the program still would create a polygon. And there is your knowledge about the data that you are treating, and what does it mean with these points, and whether it makes sense to interpolate neighboring points or not. That's only you who would know as owner of the data, and that's something you have to always consider. Sometimes it would just not make sense to interpolate between neighboring points for many reasons. Maybe you are interpolating some, for example, vegetation, and you know that the vegetation cannot grow at 7 meter depth, and then in one point you have 2 meter depth, and this is extreme, right? But one point you have 2 meter depth, and in the next point you have 7 meter depth. The program will still interpolate no matter how far the distance is, and sometimes you will have to use a help function, like for example bathymetry, to cut your interpolation, so to eliminate those areas where you know nothing will grow. This could be an example. But this is a bathymetry, and this is as the definition we have from the model. You notice also that if I remove the points, the last polygon that it has been created is been enlarged to fit a geo-shape, a geometrical shape. This is coast, and therefore is not true. So if you want to calculate areas with this, then you will have to do something with these very elongated polygons that you get in the corners. And you can do that by clipping with the coast, for example. Okay, so this is one way of interpolating your points to create a kind of grid. In this case, is a polygon layer, where the polygons are based on each other's, the distance between point to point. If we go back to the points, there's another way where you can interpolate your point, and instead of creating a vector file with polygons, you can create a raster file with a grid. You go again to vertical mapper, and then you state create a grid and interpolation. Then a dialog will appear with the kind of interpolations that you are allowed. Notice that in this dialog box there's a short explanation about what does it mean with this kind of interpolations, but sometimes you will have to find further information and figure out what are you doing, and what would make sense compared to your data and your aim. You can do triangular with smoothing, you can do inverse distance weighting, natural neighbor, that can be simple or advanced. You can do rectangular, V-linear, Kriging, or custom estimation points, which means you can basically add your own mathematical expression to define how the points should relate to each other in order to create a grid. Out of these interpolations, there's others like spline or spline with barriers that MapInfo doesn't include, but other programs like ArcGIS will include and make sense in some cases. Just to try something, I will try triangulation with smoothing. And then you say next. Now you have to figure out which one is your layer. I want to have this. And yes, I want the column called bathymetry, which is the field that contains all the meters in negative values as to be the value that populates my raster. Because remember, in this case, a raster file will only contain one value instead of color, and this value, in my case, I want it to be the depth. You go to the next, and then it asks you what kind of alineation you want. Again, you have to find places from where you can find it. I will call it bathy raster. And then finish. Okay, now the program have created a raster file, which if you zoom in closely, it's composed by very little raster file as a raster grids. And again, if you click anywhere in the map with your information button, then you will get a value. You should get a value. Where is the, okay, sorry, the window was in the other screen. So remember that escaping. Remember that your bathymetry, okay, every time I click, it escapes to the other window, sorry. But you can see that every time I click somewhere, the deeper it gets, the more negative the value gets. And that's how it should be. But now I have a raster. So if by any case you want to transform your raster into a polygon, then what you have to do is a transformation between your raster files and a polygon or vector file. And I will do that in the next video so that it doesn't become so long.